I guess I'll start talking again since Jake maybe will just now start listening. Here was my plan that was going to work out better with 3 of you, because I'm recording now.
No, I know. I'm saying, come on, Jake.
So, I was going to have you guys, and if he's going to be out for a few days, I may set up Zoom and offer that he can Zoom in with us, because, I mean, not make him, but I'm sure he's sitting at home bored. He's probably on his computer, let's be honest. But so, I don't care how you guys prove this. I'm betting you're going to prefer a 2-column over a flowchart. But what I wanted to do to start today's lesson, because this is left over from yesterday, is let you guys, without my assistance, try to work your way through this proof and then hand it to me and say, okay, do we have everything we need? And if we're missing steps, we're going to go back and say, oh, right here we should have said this, right there we should have said that. Now, hopefully you won't be missing anything. But again, this is one of those okay, we have to say extra stuff. But we have to prove that. The only way that there is a theorem is someone proved it. We didn't. We did not prove isosceles trapezoid.
No, I mean opposite sides. So you know how the opposite side of an angle, and if it's the biggest angle, that means the opposite side is the biggest side.
But for what shape?
For any shape.
That's not. This is the biggest side.
No, it has to be a triangle. It's only
Really? Because
there's no opposite side on any other shape. Well, any odd shape has an opposite.
You guys are talking yourselves out of your argument.
That was never my argument.
Well,
I may have said yeah, but it wasn't my argument. I was just flashing on. And I was like, wait a second, that's not fun.
so you can do it up on the board if you want. I don't care. This is where I wish I had 2 screens still so I could drag this off to 1 screen. So if you want to, in your head, kind of just, we can even move this over to here if you want.
What is an isosceles? Wait, is there such thing as an isosceles trapezoid? Is that what the question? I don't get what the question is.
So Carly just proved that if the base angles of a triangle are congruent, then it is an isosceles triangle. We proved things like that yesterday, which is what Akshay was trying to argue. She wonders, though, is the same thing true for trapezoids? So exactly the question Connor just asked. You will explore her question using EFGH at the right.
No.
EFGH. But Carly, through her wonderful math teacher's advice, started by drawing some lines because she didn't quite know what to do. But she said, if I extend these lines,
it makes it a triangle.
I can make a triangle. So I want you guys to go through and prove, if we can, that EH and FG are congruent to each other.
Okay, that's what we're trying to prove.
Because if it is an isosceles trapezoid, then these 2 sides should be congruent. Obviously, EF and HG will not be. Otherwise, this would be like a parallelogram.
Otherwise, it would be a square.
Or a rectangle.
Wait, but then it wouldn't make the tip, so that'd be something weird.
Here, give me just 2 seconds. I'm going to turn this down a tiny bit. I like a little bit of background music because I don't like silence.
Music, but it's not. This background music, I'm going to insult your background music. Okay?
That's fine.
Your background music's lame.
Is lame? That's the point of it. That's how it's background.
No.
You didn't insult it. You just actually kind of made my point.
It's got to be good.
All right, what is good background music?
Like really intense rap.
Yeah.
That's what I like.
Eminem is good background music.
Yeah. Eminem is one of the people I listen to. It's pretty good.
Have you listened to D12 before?
Maybe. Not enough that I was like, hey, who wrote this song? I use YouTube music, so it just shuffles randomly.
I mean, so does mine, but
We don't have to put the statement in reason.
I mean, you can really just label those columns S and R.
Right simultaneously, right?
You are? No.
Yeah, you can.
Really?
Yeah, it's multi-touch. E.
Oh.
It's a three-pronged F. Cross.
Okay.
Hold on, I have to skip an advertisement. Hold on, give me the mouse. Give me the mouse.
No.
I thought.
All right, you're good.
You had Spotify Premium.
I'm on YouTube right now.
YouTube Hawk. Imagine using Spotify. I know. That's exactly why.
I mean, so does Mr. Hudson.
I know.
I love me some Spotify.
But it costs money.
Yeah, I know. That's one thing that I've decided I'm okay with paying for the rest of my life.
Yeah.
Otherwise, I would probably still buy CDs. But new music has slowed down since the pandemic hit. But I like ingesting new music.
Can we wait? How did we prove that this triangle was isosceles yesterday?
That's
By the way, remember, you're now allowed to use anything that we have proved previously. We can now use those proved statements in our
Wait,
proof.
last time.
I forget what
Wait,
it's
we
called.
proved that if you have two angles, the triangle is isosceles. So H triangle. There we go. HJG is isos.
Can I ask a question? So, beyond being able to say that JH and JG are congruent to each other, and beyond saying that angle H is congruent to angle G, what is defining that HJG is isosceles going to do for you?
I don't know.
Wait, what if we
Fair point.
So, I'm not saying that it's
Wait,
wrong to talk
Wait,
about that.
Wait.
Hey, I'm asking you to wait also. All I'm asking you is make a plan before you start just writing random things, because you might want to say something else first, or like kind of think about what order you want to do this in.
Okay, this is good, and then we'll do those angles.
Wait.
Okay.
What's the definition?
Jeff,
No, I'm writing it. No.
Okay. You're doing that side? Okay. Okay, and then angle E is congruent to angle F is congruent to angle H. Wait, is congruent to angle G. Corresponding angles. So.
Connor, it's okay that you tried to insult my music, because after what you did yesterday, it would take an awful lot for me to be upset with you.
Oh.
What?
Okay, well then I'm gonna need to try to do an awful lot.
Connor, like without even thinking about it, like immediately gave away his gift card
I'm
to somebody else.
insulted. You think I did it fake?
You did it pretty fast. It wasn't like, do I want this? Do I not want this? You were like very kind.
Wait, what gift card did you get?
So the only gift card that was left for the last person was Xbox, and they don't have an Xbox. So then Connor just gave away his gift card to the last person without even asking for a replacement gift card. And when I came to try to
I'm supposed to write that.
when I came to try to force a different gift card onto Connor, they were like, I don't even need one. I was like, no, you
I
do.
took the
You have to
Amazon
take
card,
one.
'cause
I would love an
Amazon card is basically dollar bill.
It is basically
Right?
cash.
Dang.
You missed a P.
And then, Akshay, I hate to inform you, but you do actually have a mistake that we should talk about from this mastery.
What? Oh, geez.
I probably have more though.
No, it's interesting, because I think you, did your own thing and disagreed with Connor and Jake. Well, so, when we're talking about special... Do you want to talk about this now, or wait till later?
I want to talk about it.
When we're talking about special right triangles... So, Connor, you can go ahead and continue if you want. So... Like 11 radical 3, 7 radical 2. What operation's holding the 11 with the radical 3? How are they attached? Is it addition or multiplication or what? Multiplication, right? So when we, in the 30, 60, 90, so that the hypotenuse is double the short leg, this is like 8x,
Okay.
right? So if we imagine, to make it easier, what is double 8x?
Wait, isn't that 64x squared?
What is double 8x?
Oh, 6x. 16x.
So not 16 plus
Okay,
2x,
yeah. Okay.
right? You accidentally thought that this was addition,
Okay.
and if that was addition, then this would happen. When you double a binomial, it would double both pieces. But it's not addition, so it should just be 16 rad 3.
Okay, got
Cool.
it.
So this is still mastery. You just made one of those silly mistakes.
Wait.
Your brain thought about addition when you were You knew it was multiplication.
Wait, when did this happen? Did you do that?
I moved it around
Okay.
because it made more sense.
Okay.
So that we can put both of these on the difference.
So the only reason that you're allowed to use corresponding is that you've already defined the parallel, right? So just remember, this is how proofs have to be built, is you have to say what gets us to that thing. And by the way, I'm not going to make you redo this, but angle E is not specific enough. Angle F is not specific enough. You would need, because there are two angle E's in the picture, you don't have to change it. But I'm just making you aware on a standardized test or like on a map test, they're going to probably use 3-point angle
Isn't that next
notation.
week?
Yes. That's also why I brought
Very
that
good
up.
they're doing it today.
Yeah,
we got a nice announcement
But
of that.
still, I'm mad about it, man. I don't like thinking
Map tests?
Yeah, I don't like
Dude, I love map
I
tests.
hate them.
They're just like an hour or two off of school.
Well, that-
It's
I don't like
amazing.
Yeah, but actually, art classes are still like 30-some minutes long.
Still, I don't
They're
like
almost full-length classes.
it. And then if you don't finish it, you have to do it the next day.
Oh yeah, because it's mostly off of, like foundations time. Isn't it?
Yeah.
I shouldn't say what I want to say.
What do you want to say?
To Akshaya's point about not finishing it,
Why? What?
I was just going to say just work faster.
Well, okay,
Yeah.
I'm sorry.
But I shouldn't
I
tell
thought were
you.
getting insulted, so
No, I shouldn't tell you that you shouldn't care about map tests. But
My
that's
mom
that's
cares
why I
about them.
won't
That's
say
the
that.
only-
Well, see, that's the
My
thing.
mom cares about it more than I do.
Okay. So,
And I will say the fact that you're headed to high school, you might want to actually do well, so the high
So-
school doesn't think you need help.
I don't know how we do this, but right. So we know this side is congruent to that side, and this side is congruent to this side. So we know that the two side minus the one side has to equal this side for both sides. But how do we prove that? You know?
No.
You not know what I'm talking about?
No.
Okay. So take
Did I
this
never
line.
give you guys back your chapter
You
5
never gave us
masteries?
a lot of tests.
Whoa! I thought we talked about these together,
No.
but I don't see corrections.
You haven't given us chapter 5.
Your chapter 6 are ready to go back, but now Jake's not here.
Can we just still have them?
Okay, so
No,
you
I'll
take
give you
that
all
one.
these back tomorrow.
That's not fair.
Well, hopefully Jake is back. But chapter 6, you're all mastered. You talked about the only mistake you needed to.
Oh, that's nice. Okay, what are you doing?
I'm no, I'm not Jake.
Okay.
Okay, then we got this length here, right?
Right.
So this is JE.
Okay.
This length is congruent to this length, right?
It's 2 times this,
No,
right?
we don't know that.
Because it. Well, yeah.
We know that this length minus this length is the same as this length minus this length
Yeah.
because they're congruent.
Yeah.
But how do we
I
write
don't
that?
know.
You know? JG minus JE. Wait.
So, do you want me to jump in, or do you guys want to wrestle with it for a minute?
I want you.
Wait, we can put GF as congruent to AG, and then we can write whatever the proof is over there.
Wait, do you know that yet?
Wait.
Yes, because of the subtraction problem.
So, you haven't written that yet, but here's the funny thing. CPM's reasoning for what you're trying to say is literally the word diagram.
What?
Yeah.
That's not.
However,
CPM.
However, what we more so normally use is things that we call like segment addition postulate or segment subtraction postulate combined with substitutions, right? So you guys have said EJ is congruent to FJ.
Yeah.
So you can substitute EJ for FJ or FJ for EJ, right? Once you said that they're congruent to each other.
Right.
You've also said HJ is congruent to GJ,
Yeah.
Yeah.
right? And HJ equals HE plus EJ.
HJ equals what?
HE plus EJ.
Oh, okay.
Yeah.
GJ equals GF plus FJ.
And then you do transitive.
And then you can substitute or transitive. Well, transitive is normally for when one is bigger than the other.
Oh.
Because if A is bigger than B and B is bigger than C, A is bigger than C. That's transitive. So, yeah. All of those things would happen
So
here.
you have to write like substitution. Would it just be substitution?
we would use a combination of segment addition postulate to show that Hj is equal to He plus Ej. And really, you could also just write diagram, right? Because we see it in the diagram. But really, it's like segment addition postulate or something. That is the fancy name for it. And then G, yeah. But for the sake of time, does all that make sense?
Yeah.
So then once we get there, what are we going to say?
That it's an isosceles trapezoid.
That if, well, so what's the if-then statement that we can make, like, at the end of what we've proved?
If you have the two base angles of a trapezoid congruent, it's an isosceles trapezoid.
Yep.
Yeah.
If a trapezoid has congruent base angles, then its non-parallel sides, right, which are the other two, its non-parallel sides are congruent to each other.
It's weirdo sides.
So now, and you're lucky I got nice on that one because that was going to be a lot of writing. So again, to these things that we're like allowed to use because somebody proved them, but we should probably talk about why.
Triangles double the... Wait, it's not actually double. Why do triangles be like that?
Oh
You
my
know?
god.
Why do triangles like when we double the lengths, we quadruple the area?
Yeah.
Because really, there's 3 of these triangles down here.
Oh yeah, there's one there, and then there's one flip.
Because if you double this length, you can fit 1, 2, and then upside down 3.
Yeah.
Triforce. So, if this is the triangle we've been given, ABC, throw in a DE. So DE is the mid-segment, right? Because they bisected these sides.
Oh, yeah. They midpointed.
They midpointed. Yes, as I said it, I was like, someone's going to correct me because this
Is it
class...
called midpointing?
No.
Uh,
Is
No.
it mid-
I mean,
segmenting?
subdivided. I'm trying to think of when you cut things up, you're subdividing.
Like specifically half.
Bisected.
I think bisect can be used for
Is it bisect?
sides as well.
Oh, okay.
I mean, I could Google cutting a length in half and see what they say. But
Did you say cut them in half? And see what they
DE
say?
related to
no, I
AB.
could Google it.
Oh.
So
Times 2. This was on our homework.
Which
I know
homework?
that. The one that we did yesterday.
Was it the one with like all the different triangles?
I don't
Like
know.
in this kind of shape? Oh.
It's 2 times the length of DE. 2 DE equals A.
How?
Oh, look.
Oh.
That's what they want to prove. Look at that.
yeah, prove the how.
Prove the how. Okay, can you go back up
Triangle
to the diagram?
mid-segment theorem.
Triangle what?
I don't know. I just
That's
made
what
it.
it's called after we prove it.
Wait, what's it called?
Triangle mid-segment theorem. It's in bold. He does not see any congruent triangles in the diagram.
He doesn't see any? Okay, well. He's kind of
Yeah.
not very big brain, as we say.
So you want me to scooch this over?
Yeah. Yes, please.
So here's the big brain right here. We have a tool that makes lines.
I'm gonna flip my timer and not say anything
I
for at
don't
least
want
5
that.
minutes.
That's weird.
No, look.
What?
Oh wait, do we have to make a proof?
Well, that's what they said. So I'm just
Yeah, I mean, you can paraphrase some things, but yes, because this one, you're gonna actually have to turn your brain on.
How do we prove that this is congruent? Wait, we need to draw a couple more lines, okay? We need to draw one more line that's the midpoint of AB.
What?
We need to draw a point at.
That's right. Right here.
There's a point tool?
There is.
I think it's, sorry. Wrong. Right,
Why are we doing that?
because it's important.
Because
Point at.
so
So
like
that we can say that these lines exist.
Why are you saying that those lines exist?
Because we need to prove that this line is congruent to that line. And then,
And how can we get there?
life hacks.
So, what should we say? So you made F.
We need to put all the givens
There you go.
So given CE is congruent to EB.
Or you can say E is the midpoint of CB.
Oh, yeah.
What?
Yeah,
You could say
E is the
E
midpoint of CB.
Is midpoint of CB. I mean, either. It depends what you think is easier to write.
I think E is the mid. Well, you don't have to do all the fancy lines and stuff. It's just regular old English.
Just regular old English. Is there really any regular English?
Yeah, the word regular. And then we need to put D as the midpoint of. Make it cursive?
No.
Okay. And then we need to put D as the midpoint of. And we can just, can we just leave the first given and not actually write two given?
I mean, really, what you're saying is both statements go with that given. So, like, you'd have a 1 next to both of those first two statements, and then a 1 next to the given.
Okay. And then F is the midpoint of AB. And that's because we made it get red. Are you saying A midpoint?
No. It works.
Well, it works. It is A midpoint.
D is the
It's
midpoint.
also the only midpoint, but
You spelled it right that time.
Wait, what?
D is midpoint.
midpoint.
No, it says A.
D is a midpoint.
Oh.
You don't need it.
You do not need to fix that. Well, in your brain, I'm sure you do.
Yeah.
A midpoint. D's a midpoint.
Yeah, there you go.
Wow, it looks like Jake wrote that.
Stop!
Slacker way to do things. No?
Stop!
No,
No, that's not right.
Yeah, it's not given. We made Connor made it. That's
Connor. The reasoning is Connor.
Wait, no. Wait, is it 2 N's or 2 O's?
2 N's
Okay.
and 2 O's like that.
Connor.
Why are there 2 O's?
I don't know.
You spelled it right. I don't know what Mr. Hudson was talking about.
What?
Except for that
Because she said, are there 2 O's? And yes, there are 2 O's, but if you put both of the
There.
O's together.
conjecture. Wow. That makes me seem smart.
Exactly.
EF is congruent to CY.
EF is congruent.
We have to
what?
prove that this. We're gonna need more space.
Okay, then.
Okay. Angle C is congruent to angle C. That's. Wait, no, we need to prove angle C is congruent. No, never mind. We don't need to prove angle C is congruent. No, that part was fine.
I know it doesn't look good.
Oh my. Okay. Calm down for a second. Can we prove lines are parallel? Like they are. But is there any way to prove it?
I mean, the converse of saying, like, these can, like, corresponding angles.
If Jake is watching this video, he's probably yelling at his computer.
So,
Hey,
like,
Jake?
silly.
You're sick, so you have no opinion.
Wow.
Sick people get no say in Connor's government.
Yep. That's how it works. Okay.
What's your end goal?
To
To prove
that,
that this triangle is congruent to this triangle, and then the
no,
end
that they're
goal
similar.
is that it's
Well, we're actually
similar by a scale factor of a
we're
half.
trying to prove
Sorry.
that 2D, E.
Yeah, so we're trying to prove AB is double the length of DE. So to get there, we're really trying to prove similar triangles.
Exactly.
Okay.
So we could just do the similar triangles.
No, I mean no offense by this. You are being extra.
Wow.
Connor's always.
Yeah.
Mathematically, you're doing the most.
So you could do.
You're being-
Are you saying that F is unimportant?
I think it's.
I think he's saying
That
that
F in the chat.
F in the chat.
Which, by the way, can you guys explain to me what that means? I mean, I know it's
Failure,
probably an abbreviation
I
for the
think.
F word, but
Oh, yeah.
I don't understand
It's
what
what
F
you
in the
say
chat
when
means.
something sad happens.
That's what we're
it comes
trying
from
to
like
prove.
streaming,
okay.
like video game.
Because somebody said, like, F in the chat for so and so, and I was trying to figure out what it meant. But
it means
I-
like that's sad.
yeah, context clues.
Everyone that's watching my stream agrees that that's sad.
Okay, that's we're trying to prove. I think.
What? CDG?
E.
CDE, okay.
Is
There is no
similar-
G.
Yeah, exactly. It's similar to C and
That
B.
does look like a G.
Why?
I'm not even messing with you on that one. It
Okay,
did
I
look
No,
like a G.
but we have to prove that it's a scale factor of 2. Wait a second.
How could we prove things to be congruent?
Wait a second. We already have side angle, side.
Exactly. That's why I was confused by
Yeah.
making an F.
But,
That sounded mean.
and we already know the scale factors too. Wait.
Connor's
Well, at least,
conjecture.
at least for two of the sides.
Connor's conjecture
Well,
is
but
unaffected.
Whoa. This
But-
is what you get for insulting
but
my music. You get
Mr.
told that your
Hudson-
conjecture is unimportant.
If we can prove that they're similar and that at least one side has a scale factor that exists, the third side has to have that scale factor.
Exactly. That's what we're trying
I'm
to
not
prove.
saying you're on a bad road.
So let's
I'm
just
saying
just
you're
saying
on
it's-
an unnecessarily
Exactly.
light
Saying Connor's
road.
conjecture is
Yeah.
unnecessary.
let's just ignore that. That never happened. Wait. Ignore that.
No, my.
I will say that is useful to remember that we can do those things and create parallel lines and create
No, no, no,
corresponding
no, no.
angles.
Oh my goodness, it's a tiny dot.
And
Okay.
the thing
You got
that
some
AD
crazy.
doesn't annoy you.
Oh my god.
Wait, what if we just take this? Wait, no. We can move that up down later.
Didn't you just say we already have side angle side?
Well,
Yeah.
we have to prove it.
No, we don't. We already proved side angle.
Well, we have to write it.
We have to
Right,
write.
Yeah, that's right there. Just move it. Why not?
No, because we have to do this first.
What is?
And then we gotta write BC over EC equals AC over DC.
Right.
Half,
What is that?
what?
How you
He's,
doing?
he's setting up a ratio. Sorry, they're setting up a ratio to relate.
Oh, that doesn't. That's
Equals AC.
What are they both equal? You want to make sure you identify.
There's a line between A.
Who cares?
Okay. That's a dot.
Perfect.
Okay.
Equals.
This looks so messy.
And that is ratio.
It's 2 over 1, not 1 over 2.
You sure?
BC stuff. BC's the whole thing. And then, yeah.
I can't just select. Oh my goodness.
No! Oh my god, you can't. Okay. And what is this? Can you write this ratio?
Does just ratio work? Because it's not given, but it's
Scale
like,
factor.
Like it's
Scale factor.
It's not given, but it is given.
Exactly.
yeah.
It's like you have to use common sense, which sometimes people don't
No,
have.
which means there is something that we have to do. It might be that we have to say that CE is congruent to EB because it's given.
So
We have to say that.
prior to that, one thing we talked about we didn't write down is well, actually, I think maybe we only talked about it on the last problem. Is like the segment addition postulate, of
Yeah.
saying AC is AD plus BC. CB is CE plus EB.
You have to write that.
And then, it's shown to us, but nobody said it yet. Then,
Why can't we just put diagram given? Easy.
then,
No. Okay.
here, give me a second.
Okay.
Because I love when you guys are complaining and then I can kind of like drop to stop complaining.
Please excuse me, Phoenix. Can I please have Leah Bauer to the office? Leah, please come to the office. Thank you.
I'm going to call it this. So, if I say CE is equal to EB and CB is equal to CE plus EB, that creates
Do we have to put the line
that
over top
ratio.
all the time or no?
for.
Like for seconds.
You talking about this line?
No, this one.
Oh. Yeah, I mean, we're probably supposed to.
I hate that so much.
Well, so you know it's not a ray or a line.
So with this, we now see that CB is 2 times CE
And that's
because we
And
said this.
We also have to do that
so
for
the
the other
reasoning is
one
the
too.
addition postulate, segment addition postulate.
Or substitution. Really, this is given essentially, right? They gave us all this.
Yeah.
Clean diagram.
And then
or
we
else.
have to do AC and
We do the same thing.
with AD plus DC too.
So what we then say is this is equal to this plus this, which means
8.
this is 2 times this.
Yeah.
So this
Because
is equal to this.
and we already knew all that.
Oh,
Then, with our reflexive property, we got what we need.
Yeah.
The triangles are congruent to each other.
No, similar.
Yeah. Yes. Sorry, they're
Triangles
similar
are
to
similar
each
with a
other.
scale factor of 2,
And then
corresponding
that
parts
was
corresponding parts of similar triangles are similar.
All right. This one, I would venture to wonder if we won't get done with it.
probably.
Oh.
It
So
took us
this is one that we've been using this year.
Flip it around.
That inside of a right triangle are 2 other similar right triangles.
Yeah.
So what are we trying to prove that they're similar?
Yeah. What are we trying to
So
do?
A, I think you already know.
Okay.
What we're trying to prove is why are all of these triangles similar to each other?
Yeah. Wow. Well, we know this side times this side. The hypotenuse of this side, the hypotenuse of this triangle squared times the hypotenuse of this triangle squared equals their base. Facts. That doesn't help though. We know they share the same other side. I'm gonna sit down. Ow, my butt hurts so much.
Oh, actually, I think they made this one easier for you. I might be thinking of a different problem. We're actually just trying to prove the Pythagorean theorem here.
Prove the
Oh, we've
Pythagorean
done that
theorem.
multiple times. You can just search up a video on TED and you find 3 great reasons on how you can prove the Pythagorean theorem.
Well, but how do we do it?
Yeah, but not like modeling a shape on the outsides of a right
Oh
triangle.
yeah, I remember. There's like
Yeah.
a square thing
Yeah, I don't remember it, but it's on TED.
where you put like the triangle all around the squares, and then it makes a cool shape,
Yeah.
and then it's cool, you know?
So why is it that we create similar triangles there?
Because we can, you know?
You know?
What's one way that we can justify 2 triangles are similar?
Angle.
Angle,
Yeah.
similarity, which is really angle.
Angle, side.
We also just did side, angle, side.
I love angle side. That one's my favorite.
So we don't have any side lengths here.
We don't have any sides? Oh, yeah, we're
We
not
have
given any.
angles.
I'm trying to.
Well, we know
okay.
this side.
We have
similar,
We
angles.
have 90-degree angles. What else do we have?
We have the knowledge that all other angles are acute.
Yeah.
So ignore your large triangle right now.
Okay.
If we
We could do angle.
look at what looks to be the smallest angle
Which is angle.
in the smallest triangle,
Oh, that's the same angle as that one.
that's the same angle as what?
The
C.
C. Because they're similar triangles. Wait, was that given to us that they were similar?
I mean, not really, because they're asking us why.
Why? Because they
In
have
that question.
one.
All right, so we know that they both have a right triangle here and here.
So that means angle B is congruent to CAD.
Why?
Because that's the only angle left.
No.
Yes.
Angle A is congruent to angle B. Angles.
Oh, so you're saying by
Yeah.
triangle angle sum theorem,
Yes.
whatever this equals.
Should've
But
been-
we're working backwards here, I feel.
I don't know.
Okay, so we're given the yellow stuff.
Yeah,
Rotation
hold
and
on.
dilation.
Hold on, did we know that purple's congruent to purple?
No, that's what Connor was asking you, but then you were like,
But then you
no.
were like,
No,
we
not
don't know
exactly,
the triangles
but
are
then-
similar.
I mean, I highlighted those because you guys said they
And you
match.
agreed with us.
No, not necessarily.
Yeah, you did.
No, you did. You actually did. You
Yeah.
can't back that.
Yeah.
But why though? We also have one side.
What do I think of the big triangle? The
Wait,
big
it's-
triangle has this right angle, the whole thing.
Right? That's a big.
And then relate it to the medium triangle has this right angle.
Right?
We're kind of running into a. We only have one angle in each triangle problem.
Wait!
What?
Wouldn't angle C be used in both the big triangle and the medium-sized triangle?
Wait
I
a
think.
second. You're right, but they're two different positions,
Yeah.
aren't they?
Yeah. You'd have to like
Because one
flip
is-
it.
No, they're not. They're not.
What?
They're not. Yeah. We
How?
can use angle to prove it congruent. Because you flip this one over like this and
Yeah,
move
and
it
then
down,
okay.
but
yeah.
angle C is the same.
That's true.
And then that means we know that the other side of angle A equals angle B. Because
What?
the triangle angle sum theorem.
Right. Yeah.
So then we know by 90 degrees minus B that angle has to, well, actually I think it's also triangle angle sum theorem, that other angle has to, wait, we don't even need to know that. Because then we have angle. You know?
So you're saying, you're okay,
Okay.
that this here is 90
Well, actually,
minus B,
it's 90.
Yeah.
Yeah.
and that this
It's also 90 minus B, but we don't even need to know that because we already had angle. So I don't. Wait, no, we did. Wait, did we? Wait.
Are we leaving at 18?
Yeah, we didn't need to know.
probably.
Okay.
So that gives us angle.
Okay, so we've got similar.
Got that they're all similar. Now
Okay.
we can erase all that.
So the reason, if anyone ever asks you why this occurs,
It's because a lot of
the
angles.
90-degree angles, every triangle has a 90 degree,
Yeah.
and then they share another one.
Either
Which
the B
then
or
they-
the C.
Yeah, then their third angle has to be congruent.
Right.
Even though it's not the same place,
Right.
that second angle that we're talking about, they share. It's literally in the same location.
Yeah.
Are we done?
Because we gotta prove the.
Because we have to prove Pythagorean theorem.
Oh.
So in similar triangles, similar to CPCTC, what can we do with similar triangles? Corresponding parts of similar triangles are similar.
That was in the last thing, I think.
So if I do,
We know DB is similar to
if I do hypotenuse,
hot.
well, I don't know, I'm just picking a side.
No, we
Hypotenuse of the big triangle. What
Over
kind of-
AB.
Over AB, so hypotenuse of the little triangle.
Yeah, I'm just looking at Carl. Carol. I have no idea how to say it.
Carl?
Okay. I'm
So
looking at-
hypotenuse, we're using the big and the little.
So then it would be AB over
So,
AB over DB because Carl said that.
wait, short side.
No, it should.
Hold on, AB is short side of the big triangle. So if we're looking big triangle on top,
Okay.
then this is now the short side.
And it should be B.
So what's the short
That's
side?
the other short side.
DV.
Yeah.
Wait, we
Like,
can't trust the picture though. That's what Jake was.
Okay, what about the medium side? So AC is the medium side of our big triangle.
Yeah. No. Well.
Yeah.
That's the
District attorney.
hypotenuse, isn't it?
No, it's over district attorney.
Wait, the medium triangle?
No, of the big.
Small
Oh
side.
yeah.
Yeah.
The
Because
big.
we're doing big triangle across the top.
But then we need your
Some
district
little-
attorney.
DA or AD, whichever.
I don't like him. Okay, and what does that prove anything about? Wait, and we have AD listed twice.
What that proves is we're out of time today, and it is time for lunch, and this will be where we start tomorrow.
Maybe with Jake. If he
Maybe with Jake. Jake, we miss you.
No, we don't.
Alright, I'm gonna go upload this video so I can get it sent to Jake as soon as possible.
Okay. Bye. Thank you.
Bye guys, have a great day. Hey, do your homework. We should probably take homework questions at some point.
Yeah, how do you do this?
How do I what?
I just told you how to do zero upon a conquered at the start of class.
Take-
Tell them that.
Take the product of your binomials and set it equal to 0.